AB material. So I have to hit it on it anyway. So we're just going to go through so that when we are ready to get to Chapter 8, we have some basic foundations remembering our calculus. There will be things you will not remember, integrals, antiderivatives, and such like that. And I'll have to review that. Is that still blue or is it clear? Okay, so we're going to learn about what the derivative tells us about our function. What does the second derivative? This is first derivative because it's hard to read. This is second derivative. And no, I don't think I have antiderivatives on the test. I don't know. Okay, use the following graph as a guide. Then how do you know if a function is increasing or decreasing? And on what intervals is the function increasing and the function decreasing? This is the derivative graph, f prime. No, it isn't. This is f. Make a letter out of me. Okay, so this is increasing, decreasing. This is a first derivative. So what's true about the first derivative as my function is increasing? This is f. Increases. Then what's true about f prime? It's greater than 0. So here's increasing from C to D. So it's increasing from A to B, right? And then from C to D. Now, the question is, do we get to close those or do we get to open them? Second derivative is always open.
Isn't f increasing throughout the whole thing because it's all positive?
No, I'm saying
That's
as f increases, what can you say about the derivative? No, it's f.
f prime addition.
You're right. Yeah, I know.
I thought you were talking about
No, when I said no, I was wrong. Okay, what about the endpoints? You have to look at the context of the problem. Most of the time, I'm going to say leave them open, but sometimes you have to close them. So read the problem carefully to see if you're going to close them. Because in particular, at the top, what's true about f prime? At x equals b and c, f prime of x is equal to what? 0. So if you want to know where a function's increasing, you're looking where the function, its derivative, is positive. It's stopped there, not increasing. So I always leave everything open, and then I double check, because sometimes they might ask a question where you have to include that endpoint. But you have to read the question. That's all. Okay, how about decreasing? You remember this from last year, right? F decreases, but if you don't remember, you look at the graph, and my function is decreasing from B to C, right? And what's happening to the derivative there, or the slopes there? F prime is what? Less than 0. So if you know the derivative is positive, then I know my function's increasing. If my derivative is negative, then I know my function's decreasing. I said that right, didn't I? If the derivative is 0, then it's stopped. Okay? Do you remember this from last year?
No.
Yeah, that's all there is.
That's what 2/8 is?
That's what the first derivative is. It's on your handout. Second derivative. What does f double prime, that says f double prime, do? And I should have another picture of it. So you know what? I'm going to take a picture because I can. And I'm going to go ahead and erase all this stuff. When I take a picture, it'll be on it. Where's my camera? I don't know why that does that. I got to have to fix that. And where is it? Cut. Now, what I'm doing here, you guys need to learn how to do for next year. Not with a smart board, but with Word. Okay. Sorry for all the extra line in there. I can't get that. No, you probably won't have iPads. You're going to need computers. iPad will not do what you need to do at college level. Use this graph as a guide. How do you know about the concavity? Now, this is concave down until I get to here. So we just call it E. Concave down. What's true about the second derivative? And that's the interval, and it's always open. F double prime is less than 0. Then what about over here? This is concave up, right? And what's true from E to D? What's true about the second derivative here? It's positive. That's right. I remember it is you're positive, you're concave up. If you're negative, you're down.
One F prime, double prime, positive. Oh, never mind.
If you go back, and I don't want to take the time, but if you go back and analyze what's happening to the first derivative, you can see why the second derivative is positive. What are inflection points? Well, it's points on the graph, so it's points in the domain. Yes. Where F double prime changes sign. Oops. So this is F double prime is going to be negative, and then F double prime is going to be positive. That's exactly what you want to say. F double prime changes sign. You don't want to say the function changes concavity there. That is what happens, but that's not how you prove it. You have to say that the second derivative changes sign. F changes concavity. Now, one of the other problems is some of you say, well, F double prime is 0. Not necessarily. Could be undefined. So I'm not even going to write it because I don't want you to even think about it. You look at a change of sign. Okay? So that one of the questions is, what about the graph 1 over x? Remember what that looks like? Yes? 1 over x looks like this. Is the concavity different? This is concave up, right? And the other side is concave down. Is there an inflection point? No, because x can't be 0. It's not on the graph. Concavity changes, but I don't have an inflection point. It's tricky. Okay, any problems with inflection points? Was that it? Okay, one last thing. Oh, how do you know a function is an antiderivative? You find the derivative. How do you know if you have factored a trinomial correctly? You multiply it back out. That's what you do. You check it. It's the same thing. If you want to find an antiderivative, you check by find the derivative. So if I say y equals x squared, then what's the antiderivative? Call it capital Y. What? X cubed over 3. What else? Plus c. You have to be really careful about those constants. Yeah, and they can't forget about the c's. Okay, how do I know I did it right? Take the derivative and see if it matches. What's the derivative of a constant? 0. That's it. Okay, it's the derivative of x cubed over 3x squared. And antiderivatives will be fairly easy. So one last test to do is to take these graphs here. Let f be an antiderivative of the function little f whose graph is shown. Okay, f is the antiderivative of this function. That means that f prime of x is equal to what? Little f of x. Okay, and you would get a point, Ori, for saying that. Yes, you would. So it says, where is my original function, my antiderivative, increasing or decreasing? I always justify first. Is the function increasing or decreasing? It's increasing when its derivative, f prime, is greater than 0. Or, in this case, f is greater than 0. So it's greater than 0 where? I don't know why I have two graphs here, but everywhere. So it's increasing, from 0 to, looks like 4 or 5. Now that's 0. But let's see, this is 3, this is 4. Let's make this 5, 4. Let's make it 5. Do I get to include the 5? Yes. Is it still positive? This is what I mean about checking those endpoints. 0, it's 0, this is 0. My function stopped. But here at 5, it's still increasing because it's positive. That's F. I want to find out something about capital F. This is the derivative of this. I did. This is equal to F prime of X. Okay. Drew, question? So it's increasing everywhere. I could draw the function. Okay, guys? Where is capital F concave up? Okay, how do you find concavity? You have to look for F double prime. Well, F prime is equal to little f. So what's F double prime? F prime. So it's concave down when the derivative of this graph right here, F prime, is less than 0. So we're down, that's this one, and it's up when F prime is greater than 0. So where is it down? Okay, F prime, that's the slope of this. What's the slope? It's positive, positive, positive. So it looks like it's going to be up from 0. Looks like it's close to 1. And then where else is the slope positive? 3 to 5. And it's down, like a frown, and it's down when my derivative here is negative. And that's between what? 1 to 3. Where are the inflection points?
1 and 3.
As x equals 1 and x equals 3, because F double prime changes sign. You don't have to go positive, negative. Just say changes sign. That's it. And now, you guys have seen this before, but if this was your first time through, this would be hard. Yes. Antiderivative integrals. It is. We didn't ask you to draw F. This is little f. This is the derivative of the antiderivative. This is the derivative graph. Yeah, you have to read this carefully. It says let f be an antiderivative of f. So if I wanted to find f, pardon? This is little f. I don't have a picture of capital F. Right, you could find the area. Now, you guys, when you do collect data, you don't collect data about the function. You collect data about the rate of change of the function. Okay, Nick and Zach? That's what you collect data about. That's why we study derivatives. You never get the function. Population growth, if you're into biology, it's how the population changes, not. I don't tell you what the population is. You look at how it changes. We try to make a good model for what the function is. It doesn't always happen. Okay, any problems with this? You remember the stuff a little bit from last year? Well, you are the best of the best.